In this video, we're going to look at a couple more systems. They don't look irregular, but what happens is abnormal from what we expect, right? We expect to get solutions, and in these cases, that is not going to happen. We're not going to get a single solution. We'll see that the final result will be a case where we would say no solution or infinitely many. So we're actually going to start with the case of infinitely many solutions here, and we should expect all the variables to cancel in a case like this. So to get started, if you approach this as normal, as you should, we should decide that 3 variables is too many to work with, and so we can kind of work our way down. Let's just go with 2 variables and use methods that we know. So find a variable you'd like to cancel. It doesn't matter, but also at the same time, it seems that the first variable here will be relatively easy because this x has a 1, and so we can multiply this x by anything pretty easily to make it match any other x values in order to cancel. So what we need are 2 equations with just 2 variables instead of having 3 to work with. So let's go ahead and try that. Very quickly here, if we want to eliminate x using the top 2 equations, this has a positive 2 in front of x, this has a 1, but we know a negative 2 would cancel with positive 2. And so if we choose to multiply this equation by a negative 2 everywhere, we would get a new equation that reads negative 2x. Negative 2 times positive 2y would be negative 4y. And then negative 2 times negative 4z, that's plus 8z. And negative 2 times that 7 at the end is going to be equals negative 14. So we multiply the second equation by negative 2. If we leave the first equation the same, do absolutely nothing to it, and it reads 2x plus y minus 3z equals 5, we should see that the x terms will cancel when we combine. So let's go ahead and combine these equations. And what we get, the x's are gone. 1y plus negative 4y, combine those to get negative 3y. Negative 3z plus 8z is 5z. And then equals 5 plus negative 14, that's negative 9. Okay, so we have one equation that has just 2 variables. Let's do that again with 2 other equations. I might say, hey, let's try the second and the third equation. So if we want to eliminate x again, using the second and third equation, this x at the bottom is a positive 6, has a positive 6 coefficient. If we can make this x in the middle have a negative 6 coefficient, then we should see the x variable cancel. So let's multiply our second equation by negative 6. Okay, so times negative 6, and we get negative 6x. Negative 6 times 2y is negative 12y. And negative 6 times negative 4 is positive 24z. Okay, and at the end, we have negative 6 times 7. That's going to be negative 42. So when you decide to multiply an equation by a value, make sure you are multiplying all terms and you're watching signs as you do that. We don't need to change this second equation, though, because it already has a positive 6 in front of the x. So leave that the same. We'll have a plus 3y, a minus 9z, and an equals 15. Okay. So we see the x's have opposite coefficients. They will cancel. And the rest of this, negative 12 plus 3, that's negative 9y. And 24 plus negative 9, that's positive 15. Equals negative 42 plus 15, that should be a negative 27. It looks like I forgot my z over here with the 15. Okay, so we made 2 equations that have the same 2 variables. That means we can now use those equations like we have in the past. Elimination would be a good method here because of how they're arranged. Neither equation has a variable solved. So for a third step, let's take our first equation that we made, negative 3y plus 5z equals negative 9. And our second equation, negative 9y plus 15z equals negative 27. And let's cancel something. So your choice, right? You can cancel the y's or cancel the z's. The signs match, so we're going to have to multiply by a negative to have a positive to cancel with a negative. So let's say we want to cancel the y's. They're written first. 3 goes into 9, so that's pretty easy. And you decide to multiply this one by negative 3. So we multiply by negative 3 right here. And what would we get if we had that? We'd have positive 9y, which is good. That'll cancel with the other y. So we have positive 9y now. Negative 3 times the 5z is negative 15z. Negative 9 times negative 3 is positive 27. We don't need to do anything to the second equation because it already had a negative 9y to cancel. And you might notice now we have a plus 15z and negative 27. And so when you combine these two equations, 9 plus negative 9 is 0. Negative 15z plus 15z is 0. So we have 0 on the left side equals 27 plus negative 27, also 0. And this is a true statement. 0 is always equal to 0. So this is a case where our equations always have the same solutions. And so that is why we say there are infinitely many solutions. When you get a true statement in the end, we interpret that as infinitely many. And we kind of like these because the work stops early. There's not as much for us to do. Okay, so there's a case of infinitely many. Let's look at just one case where it's no solution, a very similar idea, right? We should see the variables cancel on that one too. So let's look at these, see what we want to do. You could cancel any variable that you want. The y's would be pretty easy because there's a negative 1, and 1 is easy to work with. Although any of them would be fine because x has a 3, and 3 goes into 6 and 9, so we can work with that. And z's would be fine as well. 2 goes into 8, 2 goes into 12. So whichever you want to choose, if you want to stay with x because that's what you're comfortable with, that's fine. Let's go ahead and try that. Let me get rid of this, get it out of my way real quick. Okay, so to cancel the x's, we have a positive 3 in the top, positive 6 in the bottom. If we choose to multiply this top equation by negative 2, that should help us out because multiplying 3 by negative 2 up here, we would get negative 6x. Negative 2 times negative y is plus 2y. Negative 2 times negative 2z is positive 4z. And that is equal to negative 2 times 4, which is negative 8. Okay. So let's see what happens next. We take our second equation, and let's see. We do nothing to it. It already has a positive 6, doesn't it? So positive 6x plus 4y plus 8z equals 11. Okay. And so we cancel the x's. They're gone. 2 plus 4 is going to give us 6y. The 4z and 8z combines to 12z. And negative 8 plus 11, that gives us 3. Okay, so let's try this again with two different equations, but let's get rid of the same variable we did that time. So if we want to cancel with the 3x and the 9x, we can make this say negative 9 by multiplying by a negative 3. So multiplying through by negative 3 is going to give us negative 3 times 3x, that's negative 9x. Negative 3 times y is positive 3y. Negative 3 times negative 2z is positive 6z, equals negative 3 times 4 is negative 12. And our last equation will do nothing to it. It already had a 9x, and then it had a plus 6y, a plus 12z, equals a negative 3. Because the x's will cancel, we will combine our equations. 3y plus 6y is 9y. 6z plus 12z is 18z. And negative 12 plus negative 3 is negative 15. Okay, so there we go. We have our two equations that have the same two variables. They both have a y and a z. We can match those together, stack them. And we have 6y plus 12z equals negative 3. Or sorry, equals positive 3. And 9y plus 18z equals negative 15. Okay, so this is set up for elimination again. If we're going to cancel one of our variables, we're going to need to multiply. So you can choose whether you think y is easier or the z is easier, probably the smaller numbers to work with. And you can either think of the least common multiple of these two numbers. What do 9 and 6 both go into? The answer is 18. Or if you don't want to think about that, remember you can just multiply the top equation by the coefficient 9, the bottom equation by the coefficient 6, and you'll end up getting matching values. It'll be larger values than we had to have, but it will still work. Just make sure one of them is negative to get you an opposite sign. But I recognize what the least common multiple is, so I am going to multiply our second equation by some sort of 3 to get this to be an 18. Okay, so times by 3. And if we multiply the second equation by 2, that'll say 18, but we don't want 18. We want a negative 18 to cancel with the positive 18 that we get up here. So that is why I'm going to choose to multiply by a negative 2. So let's go ahead and try that. Multiply the top equation by 3. We get 18y plus 36z equals 3 times 3 is 9. And the second equation, 9y times negative 2, that's negative 18y. That's good. Those will cancel. Negative 2 times 18z is negative 36z equals negative 2 times negative 15. That's positive 30. And so if we combine these two equations, you can see that the y's are opposite values. They'll cancel. The z's have opposite coefficients. They cancel. We get 0 on the left side. But on the right side, rather than these canceling, we get some other value. In this case, we get 39. And so we interpret that there are no more variables. We see 0 equals 39. We recognize that is not true, meaning these two equations will never have the same solution. So as far as these equations are involved, there's no solution between them. So again, we see the variables cancel when we make that interpretation. Okay, so in our next video, we're going to look at one application that we can use to solve a system of 3 equations.